Next, in the task 2, we want to delineate the spent fuel accumulation in task 1. So spent fuel will be directly disposed of. Okay, copy the input sheet task 1 and rename to task 2. And the spent fuel from PWR is disposed of without reprocessing. And now we use search string of reprocessing capacity annual tone. Again, copy from manual. Here is. And the good position is F5. Here. And in the F6, we specify how we process. In this case, we want to directly dispose, but the direct disposal is defined as one of reprocessing in NMB. So write dd-pwr in reprocessing capacity. dd- like this. And write maximum annual throughput of 100 ton till 2050. And fill below. Okay. And I want to add output of number of disposed canister and waste footprint. This is in the waste. So this one and this one. Okay, this is the end of task 2. So please run NMB. Okay, number of disposed canister and waste repository footprint is given. And the final number is 860. This is the number of canister at the end. And the waste footprint is around 100,000. Just like this. And in the task 1, spent fuel was accumulated about 500, but in the task 2, it becomes 0. Okay, and in this sheet becomes very large, and it becomes difficult to see the year and result at the same time. So as the Excel tips, in order to easily look all the result, please activate freeze pane. This display and this one. And please put cursor in the B7. Then freeze pane. And now you can see all the result, keeping the year and the name of the output, like this. Okay, let's go to task 3. Copy that sheet. In the task tree, I want to reprocess the spent fuel. And the spent fuel is reprocessed, and plutonium and uranium will be recovered and stored. Other fission product and minor actinide will be will be formed at the glass waste form, solidified as glass. And that, okay, please change TDPWR to this string, UO2 parentheses plutonium. UO2 bracket plutonium. And the annual throughput will be changed to 27 ton year. And fill below. Because in the task 1, annual output of spent fuel was around 27, so I used 27 ton annually. And please add the output of print reprocessing. Here is. And print plutonium for the inventory of plutonium. Here is. Okay, this is enough for task 3. Let's run. Okay. Let's check the output of task 3. Reprocessing means that it's here. This output means the reprocessed amount annually. So this is almost similar to the production of spent fuel, but there is 1 to 3 year delay for the cooling. And about number of disposed canister, it becomes 500 at the end. This is smaller than task 2, 800 casks. So by reprocessing, the number of ways reduced. And about footprint, the number becomes 22,000. Yes. And this is about 20% of direct disposal. So the advantage of the reprocessing is reduction of waste number and footprint. Finally, let's check the plutonium inventory. Oh, I mistake the number of columns of output should be 8. Wait 30 seconds. Okay. And this is output means the plutonium amount of uh, each material. For, for example, in the spent fuel of uranium, uh, there is some amount of plutonium. And this is reprocessed or recovered plutonium. And finally, it reaches to photons. And it continues to the end. So we don't use the plutonium inventory. In the task 4, we want to use this plutonium in PWR. Copy task 3 to task 4. To utilize plutonium in PWR, we use this keyword. This is very special in NMB and very advanced. And here is a note about atmark. I don't read it, just write this string to your input file. Or we can copy from predefined data sheet in NMB program file. In P169, we can find this string. But please do not forget to cover by parentheses. Okay, and let's put this string in I6. Like this. And in this number, in this cell, we fill 15%. This is the share of plutonium MOX fuel in the PWR. So 20 years is enough. Okay. And I want to add output string of this one, print plutonium ratio in new fuel. Print plutonium ratio in new fuel, this one. Okay. Please run the NMB. Oops, I think here is some here is overlap of the this output and this output, because we have to keep 8. Okay, so every 5 was the good place. But anyway, let's continue. Point plutonium ratio in new fuel output means the plutonium content of in the MOX fuel. This is about 5% at the 2006. Sorry, and it increased till 8.3% because that plutonium content isotope vector changes during time. And let's check the power generation. In column S, we can find PWRO2 middle burn-up fueled by light water reactor MOX. And from 2007, MOX begins to produce electricity. And the amount is about 3 or 4%. And it ends up to about 0.13 and becomes constant. This is less than 15% of, no, sorry. Let's check. This is exactly the same to 15% as specified in pull thermal ratio. And about interim storage. Here, I want to change like this. Now we have the spent fuel from MOX, SLM MOX underbar PWR. It begins from 2010 and end up to 141 ton. MOX spent fuel is not reprocessed. And the number of canisters must be slightly smaller because part of electricity comes from MOX. Let's check. The number was 500 in task 3. And this becomes 460 in task 4. And footprint as well. And finally, let's look into plutonium inventory. This was around 4 ton in task 3 and reduced to 1.4 in task 4. This is the effect of the utilization of plutonium as MOX.